Now let's learn about the aerodynamic drag force. Any body which moves through a fluid, whether it's gas or liquid, is opposed by a resistance force called aerodynamic drag force. This force increases in the magnitude with the speed of the vehicle and depends on the shape and size of the car body. Thus, it's important that the vehicle has a small transversal area and also a streamlined body. Having a streamlined body reduces the aerodynamic drag force. The aerodynamic drag force, Fa, is calculated as 0.5 times the aerodynamic drag coefficient, CD, times the maximum transversal area, times the density of air, times the square of the speed of the vehicle minus the speed of the wind. If the wind is blowing from behind, then we have a minus in this equation. If the wind is blowing from the front, then this minus becomes a plus. To calculate the aerodynamic drag power, we have to multiply the aerodynamic drag force with the speed of the vehicle in meters per second. This gives the equation of the power the same as the equation of the force, with the exception that the speed of the vehicle is at the power of 3. In this equation we used air density in kilograms per cube meters, which is equal to 1.202 kilograms per square meters. This value is valid for dry air at a 20 degrees temperature and 101 kilopascals of pressure. Also, if you want to convert from speed of the vehicle in kilometers per hour to meters per second, we have to divide the kilometers per hour value to 3.6. Moving forward, let's understand what the drag coefficient and frontal area are. The drag coefficient can be defined as the aerodynamic quality of the shape of a body in a flow. Depending on the shape of the body, the drag coefficient can vary a lot. In this image, you can see different shapes with their corresponding drag coefficients. Ideally, to minimize the aerodynamic drag force, the car of the body should be as close as possible to a streamlined body. The frontal area of the vehicle is often given by the manufacturer, or it can be approximated using a reference grid as in the picture below. One way of calculating the frontal area is by multiplying the width of the vehicle with the height and also with the coefficient 0.9, which represents the fact that the shape of the transversal area is not an exact rectangular area. For example, in this table we can see 4 vehicles with their corresponding model year and their values for aerodynamic drag coefficient, CD, and maximum frontal area. The values for Tesla Model 3, which is the drag coefficient of 0.23 and the frontal area of 2.22 square meters, which are going to be used further to calculate and size the torque and power of the electric machine.